Hello there, welcome to Pre-Cal Lecture 4.3, where we're going to be talking about the present and future value of money. We've got pre-printed notes for this lecture, and on the board here I put the compound interest formula, and I put an asterisk there. You've got to memorize that. But here's what all of the variables mean. F means future value of the investment. P is the present value or the current value of the investment. R is the interest rate. M is the number of interest payments per year. We call that compoundings per year. And then T is the number of years that the money is invested. So let's get straight into some, and you'll want your calculator handy. Let's get straight into some example problems here. So the first one says, what would be the future value of $9,000 invested in a 5% interest rate compounded semi-annually for 9 years? Okay. So what we've got here, we're going to be using this equation. This is the most straightforward type question because we're just solving for F. So if you look at the question again, what's the future value of $9,000? So our present value is $9,000. We're going to multiply that by 1 plus. Now the interest rate is 5%. We have to convert that to a decimal number, 0.05. Okay, so we're right here in the equation, the R. That's the same as 5%. So we've got to divide 5 by 100 to get 0.05. Now the number of compoundings per year, how often is the interest paid every year? Semi-annually means twice a year. So that's 2. All right, and then MT, you would have in the exponent here 2 for M, and then we're doing this, if you look at the problem, for 9 years. Okay, so F is equal to 9,000. Now I like to chop this up just to make sure I don't make a calculator mistake. What's in the bracket here? Well, that's going to be 1 plus, and I'm going to put left parenthesis, 0.05 divided by 2, right parenthesis. That's 1.025. Okay, so that's what's in the bracket. And then we know 2 times 9 is 18, so we're going to raise that to the 18th power. So we've got 9,000, so I'm just going through this equation here, times 1.025, hit the caret, raise that to the 18th power, and hit enter. And you've got 14,000, so we're talking about dollars here, $14,036, and we'll round that to 93 cents. All right, so that's what's the future value of $9,000 invested at 5% interest would be after 9 years. All right, let's take a look at the next problem on the page. So it says how much money should be invested now. Now is the present value. To have 25,000, that's the future value in 30 years. Interest rate is 6% compounded monthly. All right, so how many compoundings per year if you compound monthly? Okay, so we're going to fill out this equation. This time we know the future value. It's $25,000. We want to know the present or current value. So we have P 1 plus. Says the interest rate is 6%. We got to change that to a decimal, so that's 0.06. Number of compoundings per year, it's monthly, so there's 12 months in a year. And then it's, as an exponent, it's the number of compoundings. and the years would be 30. Okay, so I'm going to, you could put all this in your calculator at once. That is completely fine. I'm going to chop it up a little bit. Let's see what 1 plus 0.06 over 12 is. So I'm going to use parentheses. 1 plus left parenthesis 0.06 divided by 12 right parenthesis. So that's going to be 1.005. So P times 1.005, that's what's in this bracket. And then 12 times 30, 10 times 30 would be 300, and 2 times 30 is 60. So that's going to be 360. So solving for P, I'm going to divide both sides by 1.005 to the 360. So we're going to pull that under the 25,000. Now your present value is going to be less than your future value because it's going to be earning 6% interest, this present value, over the years to get to 25,000. So you'd have 25,000 on top over 1.005 to the 360th power. Okay, so let's put that in the calculator. 25,000 divided by, I shouldn't have to use parentheses here. Let's see, 1.005 raised to the 360 power. 4151.05 if we round. So 4105, and that is correct. So there you go. In 30 years at 6% interest, that amount of money will turn, it'll grow into 25,000. All right, cool. So if you flip your notes over to the back, we're now in section 4.3.2. And this time we're going to, instead of solving for F or P, we're going to solve for interest rate. So our first example on the back is what interest rate is needed to earn $2,000 on an investment of $100,000 during a 6-month period. Okay, 6 month. We haven't dealt with times less than a year of that. So 6-month period. And assume interest is compounded monthly. All right. So let's fill in the information that we know. We know that the future value is going to be 100,000 plus 2,000. So the original investment plus the 2,000 interest you've earned. The current or present value is 100,000. So we're going to multiply that by 1 plus, we don't know R, that's what we're solving for. The number of compoundings per year, it's monthly, so that's 12. And it's 6 months. Well, M is in years. So 6 months would be a half of a year, so 0.5. So that is 6 months. And then, so that's the T, and then the M is 12. Okay, the easiest way to solve these, I think, is to, first of all, let's move that 100,000 underneath. So we'd have 102,000 over 100,000 is equal to 1 plus R over 12, and 0.5 times 12 would be to the 6th power. So if you take 102,000 divided by 100,000, you will get 1.02. So that's equal to 1 plus R over 12 to the 6th power. So what could I do to get rid of that 6th? That 6 there, because that makes it hard to solve. We could take the 1/6 root of both sides, which your calculator handles that really well. So that's like 1.02 to the 1/6 power is equal to 1 plus r over 12 to the 6th power, and then all of that is raised to the 1/6 power. As long as you raise both sides to the same power, it's still an equivalent equation. So if you put in your calculator 1.02 and raise that to the, I'm going to use parentheses, 1 divided by 6 as the exponent there. I don't know if I have to, but it's always good to be careful. You don't want to round this too much. Let's go all the way out at least 4 decimal places there. So that's 1.0033. If you round too much, you won't get a very accurate answer. So try to go out at least 4 decimal places. And then here, 6th raised to the 1/6, that just cancels out, and you just have 1 plus r over 12. Now if we subtract 1 from both sides, we would have 0.0033 is equal to r over 12. And then if we multiply both sides by 12, so we've got 12 times 0.0033 is equal to r. All right, so 12 times 0.0033 is going to be 0.0396. But we need to convert that to a percent by multiplying it by 100. So that's going to be 3.96%. We always signify interest rates by percent. So multiply, move the decimal place 2 places to the right, and that's your interest rate. All right. So there you go. Pretty cool that we can take the 1/6 root of something really easily with our calculators. All right, let's do one last example. Still using this future value equation. So it says, suppose $220.80 is compounded annually for 3 years. At what rate would it need to be invested to yield a total account value of $330? All right, which one is the future and which one is the present value? Well, the future value is going to be the larger one because it's growing. So we'd have 330 is equal to 220.80. So that's my P. This is F, this is P. Times 1 plus, excuse me, just a second. To take a little drink there. Frog in the old throat. Okay, we don't know R. It's compounded annually. That means once a year. So M is just 1. All right? That's annually. So just once a year. That's a lot of times what we think of when we're calculating interest rates. And then it's 3 years, so M times T. M is 1, and the number of years is 3. So let's bring that 220.80 underneath. And that's going to be equal to 1 plus R over 1 is just R, right? So 1 plus R cubed. So 330 divided by 220.80 is 1.495. All right, so don't round too much. And that is equal to 1 plus R cubed. So let's take the 1/3 root of, it's got to be both sides, each side. If you only do it to one side, that is not legal. It's no longer the same equation. So 1.495 to the 1/3 root is equal to 1 plus r cubed taken to the 1/3 root. So 1.495 raised to the 1 divided by 3. I like to put them in parentheses just to be sure. That's 1.143. And then the 3 and the 1/3 cancel out when you multiply, is equal to 1 plus r. So subtract 1 from both sides. You get 0.143 is equal to r. So changing that to a percent, move the decimal place 2 places to the right. That's going to be 14.3%. All right, cool. So your homework is, just like these, you've got one of them that may be a little bit troublesome in terms of figuring out what M is or figuring out the number of years. You might have to do a little calculation, but it's similar type problems. So the homework is worksheet 4.2, 4.3, and finish it up. So do 7 through 12. I'm not going to give you really any hints. It's using this equation. I want to see if you can figure it out. Anything that's a little bit tough, see if you can figure it out on your own. All right, that'll do it for this lecture. Talk to you on the next one.